Hello, happy people. This is Mr. Wilcox, and this lesson is for Algebra 2 and our first unit of reminding ourselves what we did in Algebra 1. So we've talked about equations, and then we talked about inequalities, and inequalities last time had only one symbol. Today we're going to talk about compound inequalities, which have two inequality symbols in them. So how they're connected. A compound inequality is just like a compound word. So just like butterfly or waterfall, take two separate things and put them together. So in math, how we put things together, we either join it by the word and or by the word or. So either things are going to both be true or we can have one or the other. So let's start by looking at and. So and inequalities, those are compound inequality. That is the intersection of two graphs. So they're going to come together to make one graph. The range of the values have to be written from least to greatest always. So in our example, x is less than or equal to 1 and x is less than 2. This is the one and only time you'll see it with the word and, because and inequalities are always written from least to greatest as one inequality with two symbols. So -1 is less than or equal to x is less than 2 is our and inequality, and it shows our range of values. So x is bigger than or equal to -1, so we have closed dot going to the right, and it's also smaller than 2, so we have an open dot going to the left. So all that's shaded are the values in between. The only values that make both of those things true are the values in between, so it kind of makes a dumbbell. So an example of an and inequality would be in high school. You are usually between the ages of 13 and 19. So you would say 13 is less than or equal to the age x is less than or equal to 19. So graphs, you're always going to see them. Graphs are always going to have a dumbbell look, and you're always going to see them as one inequality with two symbols. All right, so let's talk about solving and inequalities. All right, so where you're going to be given an inequality, one inequality with two symbols. So we have 2 is less than x plus 5 is less than 9. It's always going to go from least to greatest, and our answer always has to go from least to greatest. So what we're going to do is we're going to solve in the center by getting the variable alone, just by following our steps of solving. And whatever we do to the center, we must also do to the left and right. So we're used to doing whatever we do to the center, we do to both sides. Now we have to do it to the left and the right. So we're actually going to be doing whatever we do in the center, we do it in 3 places, okay? And then we're going to graph our answer. So let's actually try this example of 2 is less than x plus 5 is less than 9. So to solve it, we're going to start in the center. To get our x alone, we're going to subtract by 5, and whatever I do in the center, I must do to the right, and I must do to the left. So see, I'm doing it in 3 places on each side of the inequality symbol. So 2 minus 5 is -3. X plus 5 minus 5, our 5's cancel out. We're just left with an x in the middle, and is less than 9 minus 5 is 4. So we know we're done when we just have a variable left in the middle. So here we just have an x in the middle. And then we have to graph our solution. So make sure you make a graph that is big enough to have both your numbers on there. All right. So since we have x is greater than -3 or -3 is less than x, remember that gives us an open dot. Because if I put -3 right there, it wouldn't make any sense. And then 4, I also have a less than symbol, so I'm going to put another open dot, because if I put 4, 4 is not less than 4. And the numbers that make this true have to be bigger than -3 and smaller than 4. So it's all the numbers in between those open dots are bigger than -3 and smaller than 4. Right? So this is our solution right here. So notice our solution goes from least to greatest, and our graph kind of looks like a dumbbell because it's got two open dots and we're shaded in between. So if and inequalities give us a range of values from least to greatest, or inequalities give us two separate directions. So a compound inequality is considered the union of two graphs because it's just two graphs put on one number line. So, and they should always go in opposite directions because it's an or. So our example is x is less than 7 or x is greater than or equal to 11. So we want an open dot at 7 going to the left, closed dot 11 going to the right on one graph because we can choose either or to be true. So either we're going to pick a number like 6, which is less than 7, or we're going to pick a number like 13, which is greater than or equal to 11. An example of real life or inequality, if you go to Noah's Ark and you go on that stingray ride, the one where you go upside down, you cannot go on that ride if you weigh less than 90 pounds or if you weigh more than 250 pounds because you don't have enough centrifugal force, so you will get stuck. So you can't go on the ride if you're less than 90 or greater than 250 pounds. So that's going in opposite directions. So that's an or. So here's what we're going to do to solve or inequalities. So notice with the or inequalities, you actually have the word or in there to begin with, unlike the and one. So you're going to have two separate inequalities. That should help you remember that you're going to go in separate directions. And what you're going to do is you're just going to solve each inequality like you would the other day. So just solve 2x plus 3 is less than 9. Then solve 3x minus 6 is greater than 12. Put the word or in between your solutions and graph them on one graph. So let's actually do that example of 2x plus 3 is less than 9 or 3x minus 6 is less than 12. So I'm going to start with the left-hand side here. So 2x plus 3 is less than 9. First thing I'm going to do is subtract 3 from both sides. So we'll get 2x is less than 6. And then to get the x alone, I'm going to divide by a positive 2. And because it's a positive 2, I'm going to keep my symbol the same. So I get x is less than 3. Right? So I'm done with that one. So now I'm going to go over to 3x minus 6 is less than 12. The opposite of subtracting 6 is adding 6. So we're going to add 6 to both sides. So you'd get 3x is greater than 18. And then to get the x alone, I'm going to divide by 3 on each side. So I get x is greater than 6. So I have my variable alone and bigger than a number. So now we're going to put the or in the middle. And we're going to graph it all on one graph, making sure we make it big enough that both numbers show up on the graph. All right. So we have x is less than 3. So remember that's an open dot because we don't have a line underneath. So if I put in 3, 3 wouldn't be less than 3. What number is less than 3? 2 is less than 3. Yes. So I'm going to shade to the left. And then or x is greater than 6. So I put an open dot on 6 again. And then which numbers are bigger than 6? Well, 7 is. So I'm going to shade to the right. So my graph goes off in either direction, showing that my solutions go off in either direction. So here's my solution. X is greater than 3, or less than 3, sorry, or x is greater than 6. All right, so I have one more example for you, and then we're going to graph and solve. So ands we're going to do an example of an and, because what can happen is, remember when we divide or multiply by a negative number, our symbols can switch, and we're going to have to switch them back so that our answers go from least to greatest. So we're going to practice one like that, and then ors, remember, we've been practicing those all along because you're just solving those separately. So we're going to do one more example of an and this one we're going to have the added step of having to switch our symbols. So First step, how do I solve in the center if I have -1 is less than or equal to -5t plus 2 is less than or equal to 4? Well, the first step in getting the t alone would be to subtract the 2 from the center. Whatever I do to the center, I must do to the left, and I must do to the right. So -1 minus 2 is -3. It's going to be less than or equal to 5t. Less than or equal to, and 4 minus 2 is 2. So then we're going to, that's a -5t. Then we're going to divide by -5 to get the t alone. We have to do it on the left and the right. So we're dividing inequalities by negative numbers. We got to flip our symbols. So we have 3/5. Instead of being less than or equal to, it's going to be greater than or equal to t. And then we have -2/5. Instead of being less than or equal to, it's going to be greater than again. So notice our solution is still a range of numbers, but now we go from biggest to smallest, which in the math world doesn't really make sense. You wouldn't say that in order to be a teenager, you have to be between 19 and 13 years old. You would say between 13 and 19. All right, so we always go from least to greatest. So we're going to flip this around. So we're going to start with our -2/5 is greater than t. So if I flip that around, my -2/5 comes first. Notice my inequality was pointing to -2/5 and it was eating the t, so we're going to keep that the same. It's less than or equal to t. All right. Then we want to make sure we get the 3/5 is greater than t, so our t, we want it, our inequality symbol pointing to the t and eating the 3/5. All right, so I just flipped this whole thing around. They are exactly the same. They mean exactly the same thing. I know because my inequality here is pointing towards the number and eating the t, just like it was here. And for the 3/5, it's eating the number and pointing towards the t. So now we can go ahead and graph our solution, making sure that our graph is big enough for each part. So I'm just going to make this -1 and cut it into 5 little sections so that this is 0, 5, and this is 1. So at -2/5, we would have a closed dot. At 3/5, we would have a closed dot. And our t can be anything in between. So it's still an and, so we still have a dumbbell shape. We still have a range. It's just fractions. All right. All right, so your homework is on page 45. There's a picture of page 45 on Brightspace so that you can do these problems. Remember, for ands, you should, whatever you do the center, you do the left and right. You should have a dumbbell shape when you're done. For ors, solve each one separately, put the word or in between, and they should go in separate directions. All right, so have a great day, Cardinals, and make it count.